In this lesson, we're going to define the trig functions of acute angles. We will start off with those acute angles in standard position, but we should be able to find the trig functions of any acute angle, whether it's in standard position or not. We'll use this to solve right triangles. So let's first look at how we define the trig functions. Remember, an acute angle is an angle between 0 and 90 degrees, and for this acute angle I've named it angle A, and angle A is in standard position, so here's my angle A. We have a point on the terminal side of angle A. The x coordinate I'm just calling x, the y coordinate is just y, and of course I know that if the coordinates of this point are x and y, then this distance is the x distance, this distance is the y distance, and of course I know r is the distance from this point to the origin and can be found by taking the square root of the x squared plus the y squared. For this right triangle, notice that this does form a right triangle with the right angle as angle C that I have labeled here, where R is the side across from the right angle, and if you remember that the side opposite or across from the right angle is called the hypotenuse, R is the hypotenuse. We call the other two sides of a right triangle the legs, and so if you will notice, the Y is the side. It's actually the length of the side, but it is the length of the side that is opposite of angle A, and of course it is a leg. And then this side is next to angle A, and we say that it is the side adjacent to angle A. So X is the side adjacent to angle A, Y is the side opposite angle A, and these are both legs. We only define opposite and adjacent for the acute angles in the right triangle. Now, given this definition, let's define the trig functions of angle A. We know that the sine of angle A is defined to be y divided by r. So using those relationships, opposite, adjacent, and hypotenuse, y is the leg that is opposite angle A, so we'll write opposite divided by r is the hypotenuse. And so if we had an acute angle in a right triangle and we knew the length of the leg across from angle A and we knew the length of the hypotenuse, then we could find the sine of that angle by taking the length of the opposite leg and dividing it by the hypotenuse. Probably I should write here opposite side divided by the hypotenuse. If that's what the sine is equal to, let's go ahead and let's find the cosecant. Since it is the reciprocal r divided by y, then we'll define the cosecant of angle A to be the length of the hypotenuse divided by the length of the opposite side. To define the cosine of angle A, we know that that is defined as x divided by r. X is the leg that's adjacent to angle A, so that would be the adjacent side divided by r, which is the hypotenuse. Let's go ahead and get that reciprocal relationship. That would be the secant of angle A equals r divided by x, which would be the hypotenuse, divided by the length of the adjacent side. For the tangent of angle A, that equals y divided by x, which y is the opposite side, divided by x, which is the adjacent side. And last, let's put the cotangent, which of course is the reciprocal of the tangent. So it would be the adjacent side divided by the length of the opposite side. Now, I have a summary of these. When we are defining the trig functions for the acute angles in a right triangle, these are the definitions that we use. You need to memorize sine A equals, and usually we just say opposite over hypotenuse, cosine A equals adjacent over hypotenuse, tangent A equals opposite divided by adjacent, and then usually for the reciprocal functions, I just think of them in terms of their reciprocal, and this will be true for any acute angle A in standard position. Well, now I'd like for us to work a problem using those definitions, and after we get through working it, I want you to notice the relationship in the functions of the acute angle A and the acute angle B. Let's look at the problem. The problem says find the values of the 6 trig functions for angle A and angle B. Leave answers as fractions. And so here I have a right triangle. Notice that angle C is the right angle, and that's pretty standard practice. So since C is the right angle, in this case we know that the hypotenuse, the length of the hypotenuse, equals 17. So we'll make note of that. Let's find all 6 trig functions of angle A first. We know that the sine of A equals, and I'm going to abbreviate, the length of the opposite divided by the length of the hypotenuse. And for this triangle, which leg is the leg that is opposite angle A? Well, that's the 15, isn't it? So we'll put the 15 over the 17. I'm going to go ahead and find the reciprocal function just by finding the reciprocal. The cosecant of angle A then would equal 17 divided by 15. Finding the cosine of angle A, that equals the length of the leg that's adjacent to angle A divided by the length of the hypotenuse. And for angle A, the leg that is adjacent to angle A measures 8 units. So that would be 8 divided by the hypotenuse, which is 17. Let's go ahead and get the secant. The secant of angle A equals 17 over 8, since it's the reciprocal of the cosine. Last, let's find the tangent of angle A. It equals the length of the opposite leg divided by the length of the adjacent leg. So opposite was 15, adjacent was 8, and using the reciprocal, the cotangent of angle A then would equal 8 divided by 15. So that would be all 6 trig functions for angle A. Now let's write the trig functions for angle B, and before we do that, what's the relationship in angle A and angle B? They are complementary angles because their sum is 90 degrees. Let's look at this right triangle. For any right triangle, because the right angle takes up 90 degrees, and because the sum of all 3 angles in a triangle has to be 180 degrees, that means that angle A plus angle B has to equal 90 degrees, which means that they are complementary. So keep in mind that angle A and angle B are complementary, and now let's find the 6 trig functions for angle B. We'll first find the sine of angle B, which is the opposite divided by the hypotenuse. Now when we find the functions of angle B, look at your legs. Which leg is opposite angle B? Well, it's the leg that measures 8 units that's opposite, and which leg is adjacent to angle B? Well, it's the leg that measures 15. So the sine of angle B would equal 8 divided by the hypotenuse, which is 17. And let's go ahead and write what the cosecant of angle B would equal. It would be 17 divided by 8. Let's find the cosine of angle B. That would be the leg adjacent to angle B divided by the hypotenuse, and the leg adjacent to angle B is 15, so that would be 15 divided by 17. And let's find the secant of angle B, which would be the reciprocal of the cosine, which would be 17 divided by 15. And let's see if I've got enough room. I'm going to try to keep all these on here to find the tangent of angle B. That would be opposite over adjacent, which for angle B, opposite is 8, adjacent is 15, and then the cotangent of angle B would be adjacent over the opposite, 15 over 8. Now, the reason that I wanted you to see all of these together was I wanted to see if you noticed anything. Did you notice that the cosine of angle B was 15 over 17? That's the sine of angle A, is 15 over 17. Did you notice that the sine of angle B, which is 8 over 17, equals the cosine of angle A? Notice these are cofunctions. Notice those are complementary angles. Cofunctions, complementary angles. Look at the cosecant of angle B. Let's look at its cofunction of angle A. Do you see that they're the same? Look at your secant of angle B. Look at its cofunction of angle A. And of course, last we can compare the tangents. The tangent of angle A equals the cotangent of angle B. And the tangent of angle B equals the cotangent of angle A. What I'm hoping that you see is that the cofunctions of complementary angles are equal. What we mean by that is if I have the sine of 40 degrees, it's equal to the cosine of the angle that's the complementary angle of 40 degrees. And what's the complement of 40 degrees? Well, it's 90 subtract 40. It's 50 degrees. If I had the cosecant of 30 degrees, that would equal the secant of the complement of 30. And how do I get the complement of 30? I think 90 minus 30. So it would be the secant of 60 degrees. If I had the cotangent of 20 degrees, it would equal the tangent of 90 minus 20, which would be 70 degrees. And generically, it looks like this. Keep in mind, cofunctions of complementary angles are equal, and we get 6 more identities. These are called cofunction identities for any acute angle A. The sine of A is equal to the cosine of the complement of A, and the way we find the complement of A is to say 90 subtract A. Be sure that you write these down and that you memorize these. The cosine of A equals the sine of 90 degrees minus A. The tangent of A equals the cotangent of 90 degrees minus A. The cosecant of A equals the secant of 90 degrees minus A. The secant of A equals the cosecant of 90 degrees minus A. And the cotangent of A equals the tangent of 90 degrees minus A. Well, the next concept I want us to look at is, I want us to look at the trig functions of acute angles and see whether the individual function increases or decreases as the angle gets larger from 0 degrees to 90 degrees. So let's look at that. And what we're doing here is we're comparing function values of acute angles, and I have just named my angle A, and A is between 0 degrees and 90 degrees. And I'm not exactly sure why that's there. It's supposed to be up here, marking that this is the y-axis and this is the x-axis. And here's angle A, and actually what I want us to do is to look at these angle, consider angle A, and I've picked a point on the terminal side, and first I want us to look at this as my angle A, and I have kept this distance the same. That's my R distance, and for each of these terminal sides, I have very carefully kept that distance the same. I want us to look at the sine of angle A, and of course we know the sine of angle A equals y divided by R. And so if we want to see what happens to angle A as A increases, if we're keeping R constant, if we're keeping R the same, then what we want to figure out is what's happening to the y. So let's look at that. If this is my angle A, if I create this right triangle, can you see my y distance? Now look what happens as I increase. Now suppose that this is my angle A. What happened to my y? Well, my y is larger, isn't it? So that means that the sine of my angle is a larger number because the numerator is larger. What happens as I increase A, getting A closer to 90 degrees? Well, there's that y distance. Can you see that that y has gotten larger? Which means this fraction has gotten larger. And then, of course, we can go on to 90. We're really just talking about up to 90. And so what happens, because those y's get larger, as A increases from 0 degrees to 90 degrees, the sine of A increases. Now, which means that if I find the sine of 75 degrees, it's going to be greater than the sine of 10 degrees, because for 75 degrees, which would be out here somewhere, its y would be larger than the y for a 10-degree angle. Let's look at the cosine. And once again, I've got this out of place. I'll just put it right there. Okay, assuming that I'm going to take angle A and I'm going to look at angle A as different acute angles. And the first one I'm going to look at will be just this as my angle A. Once again, I chose my R's, I chose my points so that they were the same distance from the origin, so my R is constant. That's important. My cosine of my angle is X divided by R. So let's see what happens to the X's. Okay, I know that this distance is my X distance, don't I? Okay, let's let angle A increase. Oh, what happened to that X distance? As A got larger, X got smaller, and let's let angle A increase again. Can you see what happened to the X distance? It's getting smaller as A gets closer and closer to 90 degrees. So because my R's were constant and because my X's are decreasing, as A increases, as angle A gets larger, from 0 to 90 degrees, the cosine of A decreases, and it decreases because the X's, the numerator of this fraction, the numerators are getting smaller, which causes the fraction to get smaller when R is constant. Let's look at the tangent. Now, R still is constant. The tangent equals y divided by x, and so let's look and see what happens. First, I'll let this be my angle A. There's my x. There's my y. And then I'll increase angle A. And what happened? My y got larger, my x got smaller, and as I increase angle A more, my x got smaller, my y got larger. So what happens to a fraction when the numerator gets larger and the denominator gets smaller? The fraction gets larger, doesn't it? So as A increases, as angle A gets larger, as it goes from 0 to 90 degrees, the tangent of angle A increases also. Okay, so here's the summary. As A increases from 0 degrees to 90 degrees, the sine of angle A increases because the cosecant is the reciprocal. If one number is increasing, then its reciprocal will decrease. So the cosecant of angle A decreases. The cosine of angle A decreases, and because the secant is the reciprocal of the cosine, it will increase. And the tangent of angle A increases, and because the cotangent is the reciprocal of the tangent, that means that the cotangent will decrease. Let's work some problems. Suppose ABC is a right triangle with sides of lengths ABC with right angle at C. Find the unknown side length and then find the 6 trig functions for angle B. Well, I'm going to sketch this triangle. Of course, you don't have to do that. Standard operating procedure in dealing with right triangles whose vertices are labeled ABC would be to let angle C be the right angle. And it doesn't matter on your 2 acute angles which one you label angle A and which one angle B. That's how I'm going to label my triangle. Side C, which of course is across from the right angle, would be my hypotenuse, so I know that that length is 12. Side A equals 7, and of course we label the side across from angle A as little a, which is 7, and what I need to find is side B. So since side B is a leg, using the Pythagorean theorem, I know that B equals the square root of the hypotenuse squared minus the other leg squared. So 12 squared is 144. Subtract 7 squared is 49. And what I get is the square root of 95 when I subtract that 49 from 144. Now, the square root of 95 does not simplify, so I'll have to leave it like it is. So let's find the 6 trig functions of angle B. We'll start with the sine of angle B, which we know we take the leg opposite angle B and divide it by the hypotenuse, which of course the leg opposite angle B in this case is the square root of 95, and our hypotenuse is 12. I'm going to go ahead and find the cosecant of angle B, which I know is the reciprocal of the sine, so that would be 12 divided by the square root of 95. Of course, I have to rationalize that. I can't leave that radical in the denominator. So let's multiply by the square root of 95 over the square root of 95, which would be 12 times the square root of 95 divided by, and of course in the denominator I get 95. Let's find the cosine of angle B, which is the adjacent side divided by the hypotenuse, and for angle B, the leg that is adjacent to it is the 7, so we'll put the 7 and we'll divide it by the hypotenuse is 12, so we'll get 7/12, and let's go ahead and find the secant of angle B, which is the reciprocal of the cosine. That would equal 12/7. For the tangent of angle B, we know that equals the opposite divided by the adjacent. Opposite angle B is square root of 95, adjacent is 7. And then let's find the cotangent of angle B by using the reciprocal of the tangent, which would be 7 divided by the square root of 95, and then we'll rationalize. And so in the numerator we'll have 7 times the square root of 95, and then in the denominator we'll have 95. So that would be the 6 trig functions of angle B. Let's look at some cofunction problems. Write each of the following in terms of a cofunction. Assume that the angle in which the unknown appears is an acute angle. Well, if we're going to write this as the cofunction of the sine is the cosine, and then we have to figure out what angle. Well, it's cofunctions of complementary angles that are equal, so we need to figure out what angle is the complement of 64.2, and to do that we'll take 90 degrees and subtract 64.2 from it, because that's how we find complementary angles. Let's borrow. We'll end up with 10 here. 2 from 10 will leave us with 8. Borrowing, we'll have 4 from 9 will leave us with 5, and since we borrowed 6 from 8 will leave us with 2. So this answer would be the cosine of 25.8 degrees. For 2b, we have the cosecant of 29 3/10 degrees. Well, the cofunction of the cosecant is the secant, so the function is the secant, and what we need to find in this case is the complement of 29.3 degrees. So we'll take 90 and subtract 29.3. Once again, we'll have to borrow. The 3 from 10 leaves us with 7. The 9 from 9 leaves us with 0. The 2 from 8 leaves us with 6. So this angle would be 60 and 7/10 degrees. So cosecant and secant are cofunctions, and these are complementary angles. The cosecant of 29 3/10 degrees equals the secant of 60 and 7/10 degrees. Now look at this C problem. It's the tangent of alpha minus 20 degrees, and we know that the cofunction of the tangent is the cotangent, but what we've got to figure out is what's the complement of a minus 20 degrees. Well, what was it that we did in these two problems? When we were given the angle to find the complement, we subtracted it from 90 degrees, didn't we? Well, we're going to do the same thing here. We'll say 90 degrees minus our angle, but we're going to write it horizontally. We're going to distribute the negative, so we will have 90 degrees minus alpha, and subtract the negative, or minus a minus would give us plus 20 degrees. So what we have here is 90 degrees plus 20 degrees, which is 110 degrees minus alpha. So the tangent of alpha minus 20 degrees would equal to the cotangent of 110 degrees minus alpha. This would be the complement of this. Anytime when you are finding a complement of an angle, you just take that angle and subtract it from 90. Now let's work some problems where we need to know how the trig function values compare of acute angles. Tell whether the statement is true or false. State why or why not. Well, the first statement says sine of 60 degrees is greater than sine of 20 degrees. Now, remember what happens to the sine function when your angle gets larger? as your angle gets larger, your y's get larger, and that causes the sine of your larger angles to be greater than the sine of your smaller angles as your angle increases from 0 to 90 degrees. So this would be true, and the reason it would be true is because 60 degrees is greater than 20 degrees, which means the sine of 60 degrees will be greater than the sine of 20 degrees. On the second one, the cosine of 55 degrees is greater than the cosine of 40 degrees. Now, what happened with the cosine function? As the angle got larger, the cosine of the angle decreased. So this one would not be true. The larger the angle, the smaller the cosine. So this would be false, because as the angle increases from 0 to 90 degrees, the cosine of the angle decreases, which means in this case that the cosine of 55 degrees is less than the cosine of 40 degrees, or of course another way to say that is the cosine of 40 degrees is greater than the cosine of 55 degrees. And of course the reason that is because as the angle gets larger, the x coordinate gets smaller, which since the cosine is x divided by r, that causes that cosine function to decrease. Now let's look at the C one. Well, what we need to do on a problem like this is to be comparing either sines to sines or cosines to cosines the way we did in A or B. And so the first thing we'll do with this is to use a cofunction identity to rewrite either the left side or the right side of this inequality. I think I'll choose to rewrite the cosine of 32 degrees. I know that it's equal to the sine of the complement of 32, which of course would be 90 minus 32. So let's see, what is 90 minus 32? That would be 58. So what I can do is, in place of the cosine of 32, since it's equal to the sine of 58, I can write the sine of 58 degrees. So now, is this true? Is the sine of 58 degrees less than the sine of 32 degrees? How about it? The larger the angle between 0 and 90, the greater the sine. So this would be false, because 58 degrees is greater than 32 degrees, which means the sine of 58 degrees is greater than the sine of 32 degrees, because the sine function increases as the angle gets larger from 0 degrees to 90 degrees. That completes this lesson. Please rewind the tape before you return it. Thank you.